So in this video, I want to talk about some of the common misperceptions when it comes to the speed of different programming languages. I'm going to talk about why it might not even really matter, and if it does, 8 things you can do to speed up your R or Python code for data science or data analysis purposes. If you're new to this channel and you're keen to learn the latest tips, tricks, and tools for working more effectively with data, please hit the subscribe button for weekly videos. So this video is inspired by this question. If Python is slow, why is it so widely used for things like science and data analysis? Wouldn't languages like C++ be much faster? Now I'm going to generalize this answer to R and Python, since they're actually very similar when it comes to how they work and how they perform. A lot of times people think that Python is faster than R, but a lot of times that's actually not the case. And when it comes down to it, it's a lot to how you use that specific language. And as we go over this video, we're going to go over the 8 different ways which you can make R or Python work faster. And they're going to be very much the same steps for both of them. First up, speed is a very relative thing. Both R and Python are thousands of times faster than, say, an Excel spreadsheet, and even thousands of times faster than something like a database. Now, if you want to understand why exactly this is, then check out one of my other videos, which is comparing databases to data frames, which is going to give you a better understanding of when each technology is actually appropriate to use. If you want to check that out, I'll leave a link around here somewhere. Now, when you compare R and Python to something like C++, it is going to be slower, but here's why that might not even really matter. These days, computers are actually pretty fast, and if you're doing a piece of analysis on, say, a few million records of data, then it's really not going to make any difference at all whether you use R, Python, or something like C, because they're all going to be relatively fast anyway. A piece of analysis that's run on your computer, which takes maybe 10 seconds versus 30 seconds, isn't really going to make a very big deal. Where it does start to become a big deal is when you start to scale up, when you start working with really big data sets. And so when you start working with something like C++, you're getting into a lot of refinements. So the thing is that C++ takes a lot more work. It takes a lot more code, a lot more overhead to do similar sorts of things. Now, the question you have to ask yourself is do you want to spend 10 hours to maybe save 1 second of processing time on a computer? Now, the thing is this. If you have a process that runs 1 billion times, well, 1 billion times 1 second is something like 32 years. So if you have enough data and you have processes which are running at scale enough times, then optimizing your processes makes a lot of sense to do. And this is where C++ can make a lot more sense to use. But the thing is this, with data science and data analysis, a lot of times what we're really doing is we're doing experimentation. We're kind of iterating through various things. And high-level languages like R and Python are just much faster to do that. You can take a single line of code and run it, and it will run right there on the spot. Now with something like C++, you have to have all of your code working, and you have to compile it before you can even run that application. And so there's a significantly more overhead when it comes to writing one of these type of applications. Now we have new languages as well, like Julia, and it gets a performance boost as well because it also compiles its code. Now, compiling, by the way, basically takes code that we write and it condenses it down into a machine language which can be processed by the computer much more quickly and much more efficiently. So compiling is something that definitely can speed up your work if you're going to do it, if you're going to run that process over and over again. Again, with the experimentation stage, you might only run a process once before you go off and change it, which means experimentation is more important than how fast the processes run. Now, the thing is this, what a lot of people don't realize is that you can actually compile both R and Python code. So if you have a process which is being repeatedly run, you can actually compile that code and it will run much faster as well. Now, some of the other reasons why something like C++ can be much faster is because you are dealing with a lot of things like pointers and memory management and all these kinds of things. C++ is designed to be, well, much closer to the computer language, much closer to the hardware, and it's able to optimize the resources that we have available. Now, this was really important back in the day where all computers were basically slow, memory was super expensive, and we basically couldn't do much with desktop or laptop computers in terms of data. Now computers are actually pretty powerful, so definitely for the analysis stage, a lot of that's not really necessary. Now, an analogy that I'd like to use to maybe explain this a little bit better is, so say if you have a lot of stuff and that you want to pack into your house, you could probably just buy a bigger house. And, maybe that's going to cost a bit more money or whatever it is, but, up to a certain limit, if you can afford it, then as long as you don't have too much stuff, then it's probably going to be easier just to buy a bigger house. Now, if you live in a really expensive city where there isn't a lot of land and you're maybe moving into a tiny little apartment, then you have to try and optimize that a lot more. Again, if maybe you're an architect or a planner or something like that, and you need to try and figure out how to not just provide housing to work for one person, but you need to find space-efficient solutions that work for maybe thousands or even millions of people, then optimization is really important. And that's where things like C++ come in really handy. Now, here's the thing. When it comes to R and Python, actually a lot of the times, the underlying libraries that you call and use within R and Python are actually written in C++ anyway. They're already compiled, written in C++. And so actually you're getting a lot of that performance boost. R and Python are really just simply an interface to these other libraries. So as long as your code is spending most of its time operating within these libraries, your code will be much faster. So let's start to go into the first thing you can do to speed up your R or Python code. Now, the thing to keep in mind is that a lot of times when people are learning R or Python, they're learning base R data frames or pandas, which are both relatively old data frames, significantly slower than a lot of the different libraries that are actually available today. So they're both single core, and even though that pretty much every computer has multi-core CPUs in them, these libraries will only use one of those cores. And so they're going to run a lot slower. So there are libraries available like rdata.table, which has now also been migrated to Python, which is multi-core and runs really fast on millions, even up to billions of records if you have enough memory, and it processes that really, really fast. So learning to use the right libraries can significantly speed up your code because now everything's running in parallel. So other things that you can do to make your code faster is use commands like map instead of things like loops. Now, if you're coming from a traditional programming background, or particularly if you're working in Python, things like for loops are going to be very common and very familiar to you. Now, the thing is with loops is that they're designed to work on kind of single core, single threaded type of environments, because the way that they're designed is that you iterate over an item and you go to item 1, then you go to item number 2 and then 3, and it runs everything in that kind of linear kind of order. Now, map is a function like you might have heard of MapReduce, which has been popularized by things like Hadoop. Now, the actual MapReduce principles come from functional programming. Now, these are much more common in R than they are with Python, even though both R and Python have functional programming implementations. Functional programming is just something much more commonly used within R because it's also very good for mathematical type equations. Now, the thing with map, the easiest way to explain it is that it's like a for loop. But the way that it is different is that the for loop specifically specifies that one item runs after another. The map function basically says, I want to run this job against all of these items. Go off and do it. And so how the computer goes away and does that can be far more efficient than explicitly specifying that you want it to iterate through in a loop. This is great for making use of like kind of parallel processing. And this is why it's used on things like big data clusters, like Hadoop and everything like that, because it can take a job and it can spread it across multiple nodes or multiple cores or whatever it is. And so it can be much more efficient that way. Okay. If you're coming from base R, then you'll be familiar with the apply functions. Apply functions and map functions are basically the same thing, except the map functions have a few updated benefits. For instance, being more consistent in return types and different things like that. Okay, so the next item I want to talk about here is compiling your code. So I did kind of mention this already, that you can compile R and Python code. And yes, this does definitely speed it up and make it go faster. So the fourth item I have on my list here is experiment on smaller data sets to test your code before running it on larger data sets. Because the thing is, a lot of times people go off and they basically hit run and they run a process which maybe takes an hour or something like that just to figure out that, you know, they made a mistake, and then they have to go back, make a tweak, and run the whole thing all over again. If you iterate your code on smaller data sets that run really fast, then once you know that your code is tested and working, you can easily scale up to run it on full data sets when you go out to lunch or go home for the evening or whatever it is. And in these instances, the kind of speed isn't really going to be so much of an issue. So you're going to work much faster and if you work this way. Okay, so the next item on my list here is run analysis on local data and source to minimize load times, which can often take several times longer than processing if you frequently calling data over a slow network connection. So again, this is a really common mistake that I see people make. You know, we have to work with data which comes from all different types of locations. A lot of times that data is sitting on some network somewhere. Someone will take that data and pull it down to their local workstation in order to run the processing on it. And every time they run their process, they're pulling that data again. So this is really, really inefficient because a lot of times network, especially internet connections, are really, really slow. And so oftentimes when people do this, perhaps 90, perhaps even 99% of their actual processing time is not actually any of the data being processed. It's really just the data being transferred. So there's a few things that you can do to avoid this. One is when you copy across your data to a local data set, and then run all your analysis on that local data set continuously so that it's not having to pull the data off the network all the time. The other thing is this: a lot of times data has to go through several different transformation stages, and sometimes you can make mistakes with those transformation stages. Sometimes people reload this data into their systems every time. And again, this takes a lot of processing time. So if you structure your code in a way that allows you to rerun your analysis without reloading the data because it's already in memory, then that's going to speed up your process a lot. So something to keep in mind there. Now, the other thing, going a little bit more advanced, is using distributed computing. So when we start to look at big data solutions like Hadoop and Spark and different things like that, And in another video, I'm going to talk about why generally you shouldn't be using Hadoop and or various big data solutions. For a lot of people, this is not the right thing to do, which is one of the things I wanted to point out, since it's become a really popular topic, and a lot of people, I think, are kind of studying it inappropriately. So something I'm going to create a video on soon. So keep an eye out for that and subscribe and hit the notification bell if you want to see that. But anyway, if you are using these systems, one of the benefits of using these systems is that they're distributed systems where the data can be processed at source. What does that basically mean? That means that, for instance, if you are analyzing data for an organization which has regional offices all around the world, instead of having to transfer all of that data to some sort of local data center, which can have other implications as well, from data management issues and stuff like that, about where data is allowed to be housed and all that sort of thing. What you can do is have a distributed system where local data is processed on local servers. And basically the results are analyzed and consolidated. And this is one of the things that big data systems can do for you, even if you aren't necessarily using big data as such. So something to keep in mind there. Okay, moving on to the next point. If you have billions of records of data, then you should consider moving to a system like Spark. Again, so this is kind of a continuation of this previous item. That's base R and R and Pandas are memory-based systems. Now, this is the memory based on your computer. A single node, a single computer can be somewhat limited sometimes. And so if your data grows to larger than the size that you can cater for on one computer, and again, as I mentioned, with R and Python, even with, say, 16 gigs of RAM, which is not a huge amount of RAM to have, you can be handling 5 to 10 million records of data. So, but if you're going kind of beyond that stage, then what happens is that either it just completely won't work, or the process will run extremely slowly, because what happens is that your hard disks need to transfer data in and out, swap data with the RAM. And this will be a really, really slow process, because hard disks are very, very, very slow. Either the application handles this automatically, or you have to code it manually to be able to do this. Either way, it's going to be slow, because you are accessing the hard disks so many more times. To speed this up, you can either buy more RAM or move to distributed systems like Spark. Now, aside from Spark, there are other solutions as well. So particularly for Python, you have Dask, which is again a distributed system which allows you to process data across multiple computers. The thing is this. In order to benefit from these systems, you have to have multiple computers. And a lot of times analysts don't necessarily have this set up. When you are getting to the stage where you are setting these kind of things up, you're getting the infrastructure in place to be able to do these things, then potentially perhaps you might want to move to a more open system like Spark, which will work with R or Python or a range of many other different languages as well. So just something to kind of keep in mind there. Okay, the seventh item I have on my list here is run benchmarks or timers on your code to figure out which parts are slow and fix the slowest parts first. Again, sometimes it can be hard to get the intuition as to what part of your code is actually running slowly. It might not always be what you think it is. And so adding like little chunks of code that time how long each section actually takes to run can massively help improve the quality of your code. Okay, so lastly, learning to manage your memory. So again, this is coming back to some of the benefits that C++ has over something like R or Python is that a lot of times you are being a lot more conscious and aware of how you manage that memory. Again, once you run out of memory, your system will completely slow down or just completely stop. So if you are kind of hitting those thresholds, then learning to manage your memory effectively can make a big difference. Now, a lot of times I see people basically make lots of different copies of their data frames, and so they maybe run out of memory 10 times sooner than they actually need to. Simply removing the items that you don't need anymore can make a big difference to your code. Now, a few other kind of tips and stuff as well. There's a certain amount of memory which is allocated to different things. Now, in general, with high-level languages, one of the things that makes it more interactive and easier to use and faster to use is the fact that the computer basically makes some assumptions about what data types and everything like that you want to use. And they're going to default to larger data types, which allocate more memory. And the more memory that you allocate towards something, the less memory that's available to use for other things. So using more efficient data types is going to be a lot more efficient than using larger data types. Now, in particular, the things that probably make the biggest difference are things like strings. So a lot of times when you are doing data analysis, the strings or text fields in your data sets can take up a lot of data. And the way to kind of reduce these, because I mean, you can imagine how many characters and everything like that are in a block of text. And a lot of times these are basically categorical variables. If they're not categorical variables, you actually probably want to remove them anyway, because you don't really want kind of description notes and all that kind of thing in a piece of data analysis. So those things you should just kind of remove altogether, so they're not included in your data set. And for the things which are categorical variables, then what you really want to be doing is storing them as factors. Now, the thing is that factors aren't really string or text. They're basically an integer with a number. So if you have 10 different categories, instead of having the kind of full name for each category, I mean, it still shows the full name for each category, but instead of being stored as the full text for each one, effectively each category is represented by the number, say 1 to 10, right? And this makes processing far more efficient because it's processing like a far smaller data type and data set than if you were just using the text. So little things to keep in mind there. So just to quickly recap on 8 things you can do to speed up your code. First of all, use the fast C++ libraries available to R and Python. Things like data.table are fantastic for speeding up data frame processing. Secondly, use functions like map and reduce over things like your traditional for loops. You can definitely get some performance gains there. Thirdly, R and Python give you the option to compile your code. This makes sense to do if you are rerunning the code a lot of times without having to make changes to it. 4, test your application on smaller data sets before you run processes for hours on large data sets without even knowing that it actually works properly. 5, minimize transfer time. This basically means stop moving your data around too much. If you can, process your data in place and minimize the number of times you load and unload data. 6 is use more computers. So this is if you really don't have enough memory to get your specific job done, then it can make sense to move to clustered computing. And this is using things like Spark are great tools for doing this. 7, time your code. A lot of times you're not good to know where the inefficiencies in your application actually lie. So running some sort of timing or benchmarking can really help with that. And 8 is manage your memory. So this is unloading objects when you don't need them anymore, and also using smaller data types, or at least not using data types larger than what you actually need, because As you scale that out, it is going to take up a lot more memory, means you're going to be able to do less, process things more slowly. So again, it really depends. Like, optimization becomes important when your code starts to run slow. As you can see here, there are tons of things that you can do with your R and Python code before you ever need to start using something like C++ at all. A lot of times, if an R program or Python program is running slow, it's really probably not to do with the language, but more to do with how you're writing your code. I hope this video helps you out a lot. If you like this video, please leave a thumbs up. Thanks for watching, and I'll see you next time.